is it those password before we went and we checked the RDP, and we also did ping test, right? So let's cancel it again. We don't need, we have already captured the password. Okay, so let's recap what we have done so far. Okay, let's start from the VPC. Let me go to my diagrams again. Okay, so we created the VPC first, right? So AWS did in the EU West London, EU West 2 London regions, we created one VPC web prod VPC 1. Within that VPC, okay, so we gave the CIDR range of 10.100.16. Okay, so all the subnets will belong to that CIDR range. Okay, and after that we created 3 public subnets and 3 private subnets. Okay, and we gave slightly different, you know, IP ranges to them: 10.110, 10.120, 30, and 10.110, 10.112, 10.130. Okay, so when we created this doesn't differentiate whether it's a public or private, except the name doesn't differentiate, right? Technically there should be something which will distinguish that this is public or this is private, and that distinction comes from the root table. So if you go to next diagram here, the root table we associated with this particular subnet. Yeah, all the subnets in that public, they said, okay, for internet anywhere else, please go through the internet gateway. So this guy cannot go out. Okay, but these two can go, right? And we defined security group. So security group, as I said previously, security group is applied at the instance or interface level, ENI, and network ACL is applied at the subnet level, right? And NACL has default rule of allow any inbound and outbound. Okay, so that's not controlling much of the things. It's just the basic things. Security group is definitely doing a lot of things outside within, by default within security group is applied here or, but still the fourth one cannot talk unless you say that, okay, that security group is allowed. Okay, so this is how it is. So this is the recap what we have done. Let's go back to my ping and just check whether it's working or not working. It is still working. And my RDP session, which I connected previously, let me just check. I'm still connected to the server, and I did ICMP port opening, if you had seen that, right? And this server can go out, and it has IP address of this private IP address 10.110.210, 10.1.210.210, and this is public IP address. Now, going back to AWS console here, okay. Right. The problem here is, the biggest problem here is that, okay, I have created these instances, right? So let's say instance for the RDP server 1 in the public subnet, and the private subnet 1 we have created server 1, which is again Linux machine, and this public subnet 1 we had created one Linux machine as well. Okay, and this public subnet we have the public IP address. See, you see private IP address. Okay, and they both are attached. So you see that interface here. So network interface, there's only one interface. This interface has both public and private IP address. Okay, but to go out, they need to have the internet gateway defined, which we created in this VPC console internet gateway. We created and we associated this, attached this internet gateway with the VPC. Okay. Now, problem with this kind of provision is that stop this machine. So let's say this machine, okay, I go and I say stop this instance. So, and when I start or even the reboot, I will lose my public IP address. So whatever I had before, this one, where is it gone? This public IP address, this will be gone. Okay, so let's do that quickly. Okay, let me show that to you. Okay. So we were working on this server. Okay, so let's click on this server. Okay, and I will say I have selected this server, and I will say instance stop. Yeah, and I remember my public IP address is this here. of Windows RDP. What happens? So I say, okay, so I refresh and it successfully stopped. So I refresh it again. It actually should say stop. So I am disconnected. See my laptop. So I'm disconnected from RDP session, right? Because it is stopped. Okay. Now what happens? Let's see whether it retains the IP address or not. Okay. So it will not retain the public IP address. So let me put that in the comment here. Okay. So instances in public subnet with public IP address will lose its public IP once is stopped. Okay, or rebooted basically. Okay, this is how it works. Okay, so this is not a task, this is just information, so I'll put that in. So let me just make it a little bit more information. Okay, let's go back and start.
It loses public IP. It loses its public IP, right?
Yeah, so 10.1, 10, 210 was the most likely. Public definitely it's going to lose. Okay, so it is saying stop now. Okay, so I'm going to start it again. So private is same 210. Okay, so public IP address. So instance state start again. So I'm going to start now. So let's see what happens. So this is important bit what I'm telling you. Okay, so I will tell you then how you can assign the static IP address. Okay, so you can assign the static IP address also if you want. Okay, which I will teach maybe tomorrow because that costs money. Okay, so we'll see that. It's starting. Let's refresh. Running. And see the public IP address change now. See 13.40, right? Previously it was 18 dot something. So previously it was 18 dot something. Now this IP address is 13.40. So this is change. This was this one. So this is important note. This is okay for the trial and all those stuffs. Okay, but this is not good for the this. But what you can do is still people run this type of setup, by the way, okay, with this type of public IP address. So what they do, they don't connect them through the, they connect them through the DNS names. Okay, that DNS name will never change. So if I show you here, so details. So you, the host name is this, instance ID this. Okay, it hasn't come yet. Okay. Okay, public DNS is not there. Okay, yet. So you can, if you want, you can change the DNS name also of this server. Okay, and elastic with the elastic IP address. Okay, so elastic IP address is the static IP address. Let's see this. Okay, so I have now new IP address. Okay, so let me just make a note of this IP address here. So new IP address is this. Okay, so I cannot connect with the old IP address anymore. Neither I can ping it or I can do the RDP old IP address. So it will not connect. Okay, so let's do the new IP address. So new IP address 13.40.51.95. So let me first of all, let me put the new IP address. Okay, so I put the new IP address in RDP. I should be able to. Your password will not, should not change. Okay, will not change actually. So let me just go here, password, and put this in. So I'm connected. So I'll go to the same screen. No, not the same screen because it's rebooted. It will be a fresh screen, by the way. So yeah, so I am here now. Okay, now what we will do, Now we will also try to connect first to the okay, let's see what are the IP addresses we are getting right now. Okay, so public, this one, the private IP is this. So let me make a note. Okay, server. Okay, so let me make a note here. Server this, public IP is this, the new IP is this. Okay, private IP is this. Okay, we'll do some connectivity test. Okay, the second server is public subnet. Okay, and I'll make a note here, public IP. So public IP is this, and private IP is this. Okay, and third server is in the private subnet, which is a Linux machine. Did not create the public IP address, correct? So private IP, public IP, none. All right. So this doesn't make any sense anymore. So password, we know that, right? All right. So we will. Okay. Now what we are going to do? So we are going to connect to the Linux machine now. Okay, from the internet. So it is saying initializing. Let's refresh. It should be status as checked passed. Okay, so now let's connect to this machine. Okay, so this machine, we know what is the public IP address we need to connect. Okay, and let's look at the security here. Okay, security group, for example. So you remember we assigned a single security group in the entire this public subnets. All three public subnets has single security group, right? And that security group will define what we can connect and what we cannot. So far we said within this security group you can have the communication. Okay, you can have the RDP 3389. Okay, and ICMP we allowed. Okay, that means I should be able to ping my Linux machine. So let's see, Linux machine is this one, public IP address. Let me see if I can ping IP. Okay, ping Linux machine. See, I can ping. So I'm able to ping the Linux machine also, but I cannot connect the SSH because SSH is not allowed. Linux doesn't run the RDP, right? So Linux run the SSH. I have the PuTTY, but you remember when we created that key pair, we created with the PEM. PEM is not supported in the PuTTY, but PEM might be supported in the other SSH client. So let's see that I have another, I don't know whether I have another client or not, but I can, you know what, I can always convert this PEM into PPK file also if I want. Okay, if not, I can go to the security key pair. Okay, and I can create a new key pair also, by the way. So if you look at this key pair, right, so you can import key pair or you can delete, you can create a new key pair also. Okay, so what I will do, I will let me see if I have another SSH client or not. Okay, let me see. I have PuTTY. I have, let me try if PuTTY connects or not. Okay, so let's put the public IP address of that thing. Anyways, I can't connect this right now because SSH is not allowed. Okay, so let's allow the SSH in the security group first. Okay, where is the security groups? So I can security group, I can modify from here. I can modify from the VPC console or EC2 console both. Okay, so let's do the security groups. And you remember which security group we are talking about? We are talking about the public subnet security group, right? So in this one, so security group, we are saying we need to allow the SSH, correct? So I will edit this rule and I will say add rule. I can say custom TCP, which is port 22, or SSH, which is again port 22, correct? From anywhere I will say, and I will say save rule. Okay, now I will be able to connect, but I will not be able to log in because my key pair is not correct. Okay, so I'll say restart my session. See, you see this message now. So I'm able to at least connect, right? So what it is saying, you have no guarantee that server. Okay, this may be because I may have previously one key, but I don't know whether this will work or not. Let's see. So I said, you remember I said username, default username for the EC2 instance in the Linux. What is it? Can anybody remember?
AC2-admin, I think.
Yeah, you're right. EC2 user. Okay, EC2 hyphen user. So default username for Linux is EC2 user with no password. Okay. All right. So let's go back again. This is screen. So let me put EC2 hyphen user. Let me see if I can connect. See, no supported authentication method is available. Are you getting my point? You remember when we created this security group initially? Where is it? Where is that gone? Key pair. So try to create the key pair. So it says that here. So PEM is for open SSH and PPK is for the PuTTY. Okay. So either I can do it from here or I can do some online tool. Let's do that. Let's learn something.
Is it PuTTY gen? We need to generate the key.
PuTTY understand differently. Okay. Convert a PEM file to PPK format. Okay. One is this tool. Okay. What is the PuTTY gen? PuTTY gen also can do that. Okay. Let me see if that can do or not. Okay. What it is saying, type of this. Okay. Generate a public key and is okay. Generate, load an existing private key. Okay. Let me try. So let me. Oh, it's sorry. It's saying PPK. Okay, it's saying that PPK to PEM conversion. Okay, not the other way around. Key, generate key pair and conversion. Import key. Let's see if I can import key pair. Okay, so this is my PEM file, and let me see if I can say private key. Are you sure you want to save this key without a password? Okay, that's fine. Let me see if I can. Okay, yeah, it is now saving pp. Let me save that file. Maybe same name, doesn't matter. So let's keep the same name. Key pair 1, key pair 1. Okay, so it will put me in the ppk format. Let's see what happens. Okay, so now I have ppk as well. Okay, I have converted PEM to PPK through PuTTY gen utility. Okay, so let's see what happens, whether I am able to connect or not. So right now, obviously I can't connect. So I will have to, let's close this session. Let's open the PuTTY. You all have worked with the PuTTY, right? So I assume you have worked with PuTTY, right? So we go to that connection, SSH, authentication, auth, okay, and the credentials. So credentials, if you look at, it's saying the private key file for authentication. So I will say private key file, and I will keep pair, and I'll say this one, and I will, yeah, it's there. Okay. So now go to connections. Okay. Sorry, sessions. So sessions, and let's take the public IP address again here. Okay. So I can define this. Or you can always put the username in the Linux machine, by the way, ec2-user @ IP address. This is also you can. What's happening? A Bhargav has joined again.
Yeah, he just came from vacation. I told him to join. Yes.
Okay. Hello, Bhargav.
Hi,
You missed a lot of things, but don't worry, we'll try to recap. Okay, at some point today, only probably another half an hour or so left. But we covered very basic things today. We will continue the same things. We will recap again same things tomorrow, so that you have very good understanding of the basic, AWS networking, how this works. Okay, in the real time scenario, basically, that's what we are trying to achieve. Okay.
Yeah,
All right,
sure.
guys. So
Thank you.
yeah, thanks for joining. Anyways, so guys, I said you specify the username in the beginning also in the Linux machine and give @IP address, or you can just give the IP address and it will ask the username. But later on it will, anyways, it will not ask the password because there is no password, as I said. Okay, let's try to connect. All right, because I have given the authentication credential as the certificate PPK file, which we just imported. Anyways, so let's try to connect. And EC2 user. So voila, wow. So now we are into the EC2 instance of the Linux machine in the public subnet. So let's go back to our diagram here, right? So we are in this machine now. Okay, this machine. Okay, and let's okay, so we are in this machine. Let's try to connect, ping. So let's see if I can ping all these IP addresses, the private IP address. So let's ping this IP address first of the. If I look in the diagram, this is this server I'm pinging from this server. Okay, then I will ping this. Okay, so locally, am I able to ping or not? It will tell. It will depend how the security group is defined. Go here. Okay. So first of all, let me see what is my IP address. So there are few commands you can. So in the Windows, you have the command ipconfig. I think ipconfig doesn't work in the Linux. Linux works ifconfig. Okay, so ipconfig will not work here. Okay, it's the equivalent of the ipconfig. So ifconfig. So ifconfig command will tell you this interface ENX0 that has the IP address 10.120.70, which is this IP address 10.120.70. Okay, so now from here, first I will try to ping my Windows server, which is sitting on this subnet. So this subnet are different. Okay, so let's see what happens. So ping 10.110.210. So I should be able to ping, right? Let me try to ping another subnet, which is private subnet. And what happens? Let me see. 10.1.1.29. See, I'm not able to ping. Okay. So why I am not able to ping? Anybody can guess about this? See, routing wise, within this whole VPC, you can route within subnets by default. Okay, unless until you remove it. But there is a security group also. Okay, so let's keep this diagram open. Let's go to our. First of all, let's look at the routing table. So you remember we created two routing tables, one for the public subnet, one for the private subnet. So let's see public subnet, what is the routing first of all. So we said outside, if you want to go, we will go with this internet gateway, and local. So routing is fine. That means 10.10 entire VPC we can locally route. So this is fine. Okay. As well as look at the private subnet routing table. Locally we can route. So routing is fine. Routing is not an issue here. So what is the issue? Issue is the security group. So what is the issue in the security group? Let's go to the security group. Again, there were two security groups we created. So one security group we created for the entire public subnet range, right? So if I go to diagram again here, here. So these three subnets, public subnet we created. So these three subnets has one security group. These subnets have one security group. So this may be the reason because security group is not allowing. So this security group is not allowing communication from this security group. Okay, so let's look into this. So first look at the public subnet security group. So inbound rule we had already defined RDP, SSH, and all ICMP. Okay, and outbound by default any is allowed. So any destination allowed. Okay, now go to this security group, private one. So look, there should not be any entry basically here. So there's nothing. So nothing is allowed. So outbound is fine. yeah, but inbound we cannot, right? So what do we do here? So we we basically added the inbound rule for the private subnet. Okay, so we say let's allow few things. Okay, let's allow SSH, Telnet, HTTP, HTTPS, and ICMP. 4-5 things we will allow. Okay, or or basically what you can do is you can allow all communication, all traffic from security group also. So let's say from this security group, public security group, you allow all communication inbound. Okay, let's do this one, the easy one. Okay, so from the security group public, so if you go in this diagram, from these subnets, any instances within these subnets, we can access these subnets, these instances. Okay, that's what we are doing here. Okay, now go back to our machine here. See, ping has come back now. So this is a better way of doing the things. Okay, so why we are doing this is basically, if you remember, we made this jump server, right, which can be accessed from the internet, correct? And this jump server, we can access all these machines basically in the private subnets. Okay, so let's do one thing. Okay, how do we do that? Can we okay, SSH is enabled by default. Telnet command is not found. Okay, fine. SSH command will be there. Okay, so let's see the private subnet, private IP of this subnet now. Okay, from this machine, let me try to SSH username EC2 user @ and this particular subnet we are trying to access. So what happens here? Can we access this? I don't know yet. Actually, you will be allowed. Whether we can access or not, that will depend on the certificate. So it's letting me go there. Let me try again. So it is saying permission denied. See, I cannot access it. I'm still in the 20.70 server, which is this server, public server 1, which was I was there. But it gave me the prompt for the authentication, right? So what is the culprit here, by the way? So culprit here is basically, if I look at the directory, so Linux command for looking into directory is ls-l. Okay, so there is a file, there is a directory SSH. Okay, so let's go to that directory SSH. There's a hidden directory. Okay, ls-la. So there are known host and authorized keys. Okay, so authorized keys is there, but there is no what is this? No. So cat command is like you're viewing a file, viewing a text file. Okay, so like notepad, you see that contents, right? So cat known host. So this will say, okay, I know this host 10.1.1.29. I don't know which host is this basically, and actually I can also do I can actually install a PuTTY client in the Windows server. Let's go to Windows server. Okay, so here also I can import that PEM or what is it, PPK file, actually PEM file, because it's not a PuTTY client. So PEM file I need to put here in this directory, but how do I do that? SCP, you know the SCP command. So let's okay, let's go to Windows server first. This is my Windows server. Okay, and from here, okay, let me first try to access okay, install the PuTTY here. Okay, so that you understand what we're doing. So I'm opening the browser. Okay, so I'll say download PuTTY. Okay, so I'm installing the PuTTY client here in this RDP or the jump server of my public subnet. Okay, let's do that quickly. See, it is slow because it's a very low end machine, by the way, right? It's not a high end machine, but usually it works fine. Okay, so because start without syncing the data. First time we are opening, so it will take a little bit more time. Okay, continue and confirm and continue. Okay, please. Okay, so I'll say google.com. See how slow is it? Okay, so google.com. So when I will open google.com, because I'm in the London region, it should open google.co.uk, by the way. If I'm in India region, then it will open google.co.in. Likewise, the other countries. Okay, let's see. We might open the google.com. Okay, so I'm there. Okay. Okay. So what do you think? You has ended possibly. Why? Why ended? So this was my password of the Windows machine. So I'm just copying my password again. Okay. Just put a remember. Yes. So as we are in a free tier, though, that's the reason, you know, we are facing these kind of issues. Otherwise, this issue shouldn't. Okay. Download PuTTY. Okay. So let me PuTTY gen. Let's install this one. Okay. PuTTY for Windows. Consent and okay, so I'm going to install this MSI. Okay, so we'll download, maybe 64-bit is fine. Come on. Okay, so here this one we're going to install. Okay, 6486. Yeah, I think this is the one we need to download. MSI x86. Yeah. So add, we don't need any add here. Okay, so has this. Okay, your download will start. Okay, in 3 seconds. Let's quickly check that. Okay, click here, so it's downloaded now. Okay, so let's go to download directory. 3 MB files, it's a very small file. So in the cloud, as I said before, everything costs money. So your file transfer also, inbound, outbound. Inbound is free, by the way. Outbound is not free. So if you are sending file from AWS to outside or within VPC or so, there is a charges. Okay, unless until you have some enterprise level subscription, but those will have different cost associated. So please bear in mind. Okay, so let's go here and let's install this guy and see what happens. Huh? Okay, so probably I downloaded the wrong one. So let's go back again. PuTTY, is it 64-bit or 32-bit? Let me just check the task manager. Not the task manager, sorry. PC properties. So this is 64-bit x64. Okay. Okay. So I think we installed the wrong one. I think this one we need to install. Okay. So let's manually go back again. Yeah. So yeah, let's install this one. This should work. Yeah. Install. Yeah. Okay. So we have PuTTY here. Okay. But again, this will not work as of now. We will have to download that PEM file here by some means, and I'm going to do that. How do I do that? So let me see that. Okay. I go to PuTTY. So I'm here, PuTTY. PuTTY. Yeah, so it's here. Let me just put this in the task bar. So here, okay, here am I. So let me see what was my IP address of. Let's connect to this one first. Okay, the public subnet private IP address 10.1.20.70. Okay. So PuTTY here. So if I try to connect this one, so I should get the prompt, but I will accept and EC2 user. So it is again same error. So certificate error basically, right? So certificate, we need to by some means we need to have that certificate copied in this Windows machine, downloaded. And when I'm saying that, I mean basically the PEM or the PPK file. So question here is the file I've got in my laptop here. I want to send this file to this server, and how do I do that? So one way of doing it, I can send through my email ID also. Let me do that, email ID. Okay, let's do that. Okay, so let's let me do that. How do I do that? I mean, there are many ways of doing it, sending the file. So let me just try to guys. No, we have got only one. Okay, fine. So we got PPK, this one. Let's download this one as well. Okay, so we have both the files, and yeah, PEM and PPK. So let's do the this thing again. Okay, so you remember what we did last time. So we go to settings, right, and we go to connections and SSH, and we go to, sorry, let's close this one. Let's open fresh one. So we go to connections, SSH, and we go to auth, then we go to credentials. Okay, and here we define that certificate, this PPK file, key pair 1 PPK file, not the PEM file. So PEM file is not for the PuTTY, PEM file for the other SSH client like secure RT, for example. Yeah, open SSH, for example. Okay, so let's put the PPK file here. So see the PPK file, right? So download folder, this file. Let's, yeah, it's there now. Now open the session. So you remember the IP address, private IP addresses. So private IP addresses. So public subnet में private IP address for Linux was 20.70 and private में 10.1. So let's connect to this one first, okay? And let's see what happens. So EC2 is the username, and password it will not ask because there is no password set. Okay. So we are in the public subnet Linux machine. Okay. So let's come out of this, and let's try this one also, private subnet Linux machine. And you know that in the diagram, this machine now I am trying from this RDP server. Okay. So first I tried from this to this. Now I'm trying from this to this. Okay. So go back again here, and where the PuTTY gone? So yeah, so go here. So this time I'll give the username here itself. Okay, EC2 user @IP address. Okay, as I said, you don't have to give the username later. You can give prior also, right? So let's open. So it will, first time I'm doing, so it will say accept connection. Yeah, and hold on. No supported authentication methods available. Server sent. Why? That's interesting. Maybe that file is not saved. That is why. So I need to go auth again, credentials. So yeah, I need to save that file. Okay, so that is why it is saying. Okay. So SSH sessions, remote command. So go to sessions again. So EC2 user @private IP address of that private subnet, and go here. It should be able to connect now. So I am now inside the private machine, right? So if I show you the diagram again here, so I am now in this machine. Okay, so this machine, because this is in the private subnet, this cannot ping outside world. So if I try ping Google, IP is resolved, but it will not be able to ping because this guy doesn't know how to go out. Public subnets, we have attached one internet gateway. That's why this machine is able to go out. So let me just quickly show one more time. Let's break this one. Let's close. Let's not close this one. Let's say new session. Okay, and let me see the key is there or not first. Credentials. Actually, I can. You know what? I can save the sessions and I can save those keys as well. Okay, so let me do this thing. Okay. Actually, these IPs keep changing. 20.70. Okay, let me see if I can connect. Easy. No. So I need to define that key again. Yeah. So new session and go here. Credentials. Yeah. So now go here. Session. So what I'm trying to do here is that, so I am now connected to public and private both, right? So this is private Linux, private subnet Linux machine. If you look at the if config, so it is 10.1.129 IP address, and this one is the public one. Sorry, which one did I connect? Oh, I connected wrong one again here. Sorry, I need to connect the 10.1.270. So my mistake. Okay, so SSH auth credential ppk pair and go here. That was 10.1.20.70. You just double check that I'm doing the 20.70 here. Okay. SSH. I'm there. So this is my Linux machine in the public subnet, and this is my Linux machine in the private subnet. So this machine cannot go out because it doesn't know how to go out. Routing is not there, because that's why it is a private subnet. The other one can go, so this one can go. So you got the point, right? This machine is able to go out because it has internet gateway assigned and routing is there. This machine cannot go out because it doesn't have an internet gateway. So let me show one more time the internet gateway thing. So internet gateway is here.
So internet gateway, when it is attached to the entire VPC, why the private subnet is not going?
No, because routing is not there. So there is a routing table. Route table is there, right? Where is the route table gone? Route table. So look at one more time at the route table. So public subnet route table, what it says route? It says to go out anywhere, go via this IGW internet gateway, correct?
Okay.
And locally it can access each other. All the subnet, VPC, all the subnets, right? But for the private subnet route table which we have attached, it says locally it can access, but outside it cannot go. So this makes the difference between private and public subnet by means of the routing table. If routing table is not defining, internet gateway is not defined, or any other mechanism is not defined outside, it will never be a public subnet. Just giving the name to public or private doesn't make difference, doesn't distinguish whether it's a private or it's a routing table that makes the difference. Okay, looks like somebody Bhargav. Okay, I don't know, Bhargav, you missed something which I was talking before you got disconnected.
No, just now only there's an interruption in the network.
Okay, fine. So what I was saying, these public subnets are able to go outside because they have internet gateway attached, and we have routing also defined that to go outside anywhere in the world to go via the internet gateway. So this is the public subnet routing table, route table, which says go out anywhere, destination 0.0, and target is internet gateway. Private subnet, which we have associated with the private routing table, it says only locally route, means only within the VPC they can access each other, but they cannot go anywhere else. This is the purpose of the route table. This is extremely important in the AWS route table. Without route table, routing doesn't happen. There is no dynamic routing within here. So that is how it is. I mean, within VPC they can work each other, right? So there is a routing. By default, there's a default. You remember when we created default VPC, there was a default route table created. So those things are there. By default, they will work, okay? But you can remove them if you want, okay? There's no dynamic routing as such here. So guys, I think we should, close today's session, I mean, in next couple of minutes time. But I just want to recap what we have done and what we will plan tomorrow so that you have a very fair understanding of at least this very core, knowledge of the AWS, okay, core components. So what we did, we said AWS cloud, okay, whether AWS cloud, whether it's a Azure cloud, or whether it's a Google cloud, whatever it is, right? They all work in the concept of the region and availability zones, right? The regions are a geographical location, okay? In Europe, yeah, there can be 2-3 regions or 5 regions, right? In the different countries, basically. So we are working in the London to Europe region, which is based in the London, okay? But that doesn't tell you exactly where your actual physical data centers are. And there comes the availability zones, right? So in the AWS, there are 3 availability zones, availability zone 1, 2, and 3, okay? So for very high availability of the servers, always companies create 3 servers, 3 instances for one, server. So in availability zone 1, 2, 3. So suppose entire data center is down, for example, right? And each availability zones can be miles apart from each other, right? So there is a availability of the services. So they will put the instances in the multiple availability zones, okay? And this concept is same whether it's the AWS cloud or whether it's the Azure cloud, okay? Then we said what topics we are going to cover, okay? Some topics we are going in depth, like we have gone today, okay? Some topics may not be that in depth, but just theoretical things, but those will be very high, not high, high end topic, I would say, which is not possible because, okay? So VPC we said we'll cover, we have started covering. Subnets we are doing, availability zones we have seen, security groups is very important, which we are doing. NACL we have seen, VPC peering we'll do tomorrow. Internet gateway we have seen today. NAT gateway we will see tomorrow. EIP is elastic IP. This we will see tomorrow. Okay, so elastic IP is nothing but you see that when we create the instance with the public IP address, it is assigned with the public IP address, correct? But moment you reboot the server or stop the instance, the public IP address will be lost and new public IP address will be assigned. So to have the static IP address, we create the elastic IP address, EIP, and that we attach with the server. Okay, that we'll do tomorrow. ENI we have seen every instance is created with the network interface. In the AWS terminology, it is called the elastic network interface. Okay, route table we have seen, it is extremely important. Without route table within VPC, you can communicate within multiple subnets, but to go outside of that VPC or to go to internet or to go private to public or public to internet, it is controlled through the route table, which we have seen. Load balancers we will see next week. Okay, there are different type of load balancers. EC2 computing is actually not part of this course, but without this we can't demonstrate anything. So we have created certain EC2 instances, like we have done Amazon's Linux instance, we have done the Windows Server instance. Okay, VPN gateway will cover next week. Transit gateway we will cover next week. Direct connect, it will be mostly theoretical because we cannot do the practical of it, but I will try. And route 53 I'll show you how to done. Basically it's a DNS name resolutions. And VPC endpoint services, again I will try to cover next week. Okay, then after this I constructed this VPC. I created one VPC for you in the EU West to London region. I can show you one more time. So I go to my VPC dashboard. Okay, so I'm just doing it with Bhargo as well, so because he has joined late. So I am in the London 2 regions. So different regions are there. So whatever resources means computers, VM, or whatever you call it, EC2 instances, I'm creating VPC, I'm creating in the London region. Okay, this region I'm on right now. Okay, so it is here, you can choose from here. So London 2 regions I've created one VPC, and VPC name is web prod VPC1. So if you look at your VPC here, so I have one VPC web prod VPC1. Okay, and this has a CIDR IP subnet 10.1.0.0/16. So whatever subnets I will create, they will start with 10.1. After that I can create 10.1.10, 10.1.23, whatever it is, right? After that I created 3 public subnets, okay, and 3 private subnets. Okay, I named them differently: web prod VPC1, public subnet 1, public subnet 2, public subnet 2, and I also created those public subnet into 3 different availability zones. I could create in the same availability zones as well, by the way. Okay, but it is good idea to create in different availability zones. Okay, so this I've created, and after that I showed you one diagram how the NACL, network access list and security group, works. NACL works at the subnet level, so it controls the entire subnet. But NACL, as I said, it is a stateless firewall. It's like a router ACL, exactly same. So if you allow inbound connection, you have to allow the outbound connection as well. Okay, likewise outbound, if you are allowing, you have to allow the inbound as well. So this is how the NACL work, and by default NACL allow everything inbound and everything outbound. So we are not disturbing the NACL, and NACL is not scalable. It can support, I think, 20 or 30 rules, not more than that. Okay, so we are not doing much in the NACL. We do a lot of things in the security group. So security group is attached with the instance itself. Each instance can have its own security group, or we can have a single security group in multiple instances of that particular, subnet or private or public, right? So what we did, we created one security group for these 3 subnet, public subnet, and one security group for the private subnet. Okay, and in the public subnet security group, we allowed SSH and ICMP and RDP so far. Okay, and by default we set all the communication within in the private security group, we said allow communication from public security group. So anything, so public can access the private. Okay, that's why we were able to, from our RDP server 2, we were able to do the telnet or the SSH, not the telnet, the SSH to the Linux machines. Okay, that's what we have done, and we created exactly this kind of architecture. We created 3 servers. One server was Windows server, which we said it is our kind of, bastion server or the jump server. From there we can connect to different machines. Okay, we created one Linux server in the public. We SSH to that public Linux server as well, and we SSH to this private server from this Windows machine through that key pair. You saw that key pair, right? And we created one internet gateway, and with this internet gateway, these public subnet machines are able to go out after defining the routing table. So guys, this is what all we have done today, and I'm sure you must have learned something new today, and it must be helping you as well. I know that you guys don't have any experience or very limited experience in the cloud space, if I'm not wrong. So do you have any questions, guys? So this is the right time to ask the questions.